easy go.
Hey there, science fans. Bill Nye here, ready to launch you into the mind-blowing world of quantum computing. It's not just some sci-fi fantasy anymore. We're talking real-deal tech that's about to turn our world upside down. Imagine a computer so powerful it could crack even the toughest codes in seconds. That's the promise and the peril of quantum computing. Quantum computers are like the cool kids on the block, leaving our everyday computers looking like clunky dinosaurs. They use the quirky rules of quantum mechanics to crunch numbers at warp speed. We're talking solving problems in hours or minutes that would take classical computers billions of years. But hold your horses. Before you start picturing teleportation and time travel, let's break down what makes these quantum machines tick. Get ready to dive into a subatomic world where things get seriously weird. Okay folks, buckle up because we're going subatomic. Imagine a world where particles can be in two places at once. That's the wacky world of quantum mechanics, the science behind these super-powered computers. Instead of bits, which are like tiny switches that are either on or off, quantum computers use qubits. Think of qubits as super flexible switches that can be on, off, or both at the same time. This both-at-once state is called superposition, and it's like giving our computers a massive multitasking boost. Another quantum quirk is entanglement. Imagine two qubits linked together in a kind of telepathic bond. Change the state of one, and the other instantly mirrors it, even if they're miles apart. Spooky, right? This interconnectedness is what gives quantum computers their incredible processing power. Now, let's talk code breaking. Every time you send a message, make a purchase online, or even check your bank balance, encryption is working behind the scenes to keep your data safe. It's like a secret language that only authorized parties can understand. Most online security relies on something called public key cryptography. It's based on complex mathematical problems that are super hard for classical computers to solve. Think of it like trying to find a specific grain of sand on a beach. Tedious for you and me, but a piece of cake for a quantum computer armed with the right algorithm. Enter Shor's algorithm, the quantum world's answer to a skeleton key. This ingenious algorithm, developed by mathematician Peter Shor, is specifically designed to crack the codes that protect our online world. Remember those tough math problems that underpin encryption? Well, Shor's algorithm can chew through them like a hot knife through butter. This means that with a powerful enough quantum computer, hackers could potentially break into any system, exposing our most sensitive data. Section 5, Post-Quantum Cryptography, the New Guardians. Don't panic just yet. The good news is that the cybersecurity world isn't just sitting around twiddling their thumbs. They are already hard at work developing new encryption methods that can withstand even the most powerful quantum attacks. This new breed of encryption is called post-quantum cryptography, or PQC. It's like building a digital fortress with walls so strong that even Shor's algorithm can't breach them. PQC relies on entirely different mathematical principles that are resistant to quantum attacks. Section 6, Quantum Leaps Beyond Code Breaking. Now don't think for a second that quantum computers are just good for breaking codes. These brainy machines have the potential to revolutionize fields far beyond cybersecurity. Imagine designing life-saving drugs with pinpoint accuracy, creating ultra-efficient solar panels, or developing new materials with unheard-of properties. Quantum computers could accelerate scientific discovery like never before, leading to breakthroughs in medicine, energy, material science, and countless other fields. Section 7, AI, the Quantum Whisperer. Here's a mind-blowing thought. What happens when we combine the power of quantum computing with the intelligence of artificial intelligence, or AI? We get a technological one-two punch that could reshape our world. AI algorithms are already being used to design and control quantum computers, making them even more powerful and efficient. And as quantum computers become more sophisticated, they could turbocharge AI applications, leading to smarter robots, more accurate predictions, and a deeper understanding of the universe itself. Section 8, Quantum Quandaries, Navigating the Ethical Maze. With great power comes great responsibility, right? The rapid development of quantum computing raises a host of ethical questions that we need to address head-on. Who will control this powerful technology? How do we prevent its misuse for malicious purposes? And how do we ensure that the benefits of quantum computing are shared equitably across society? These are just a few of the thorny issues we need to grapple with as we enter the quantum age. Section 9, the Quantum Age, a Double-Edged Sword. So, there you have it folks, quantum computing is a game changer, a double-edged sword with the potential to both revolutionize our world and disrupt it in ways we can't even imagine. It's a future full of promise and peril, a future where the boundaries of what's possible will be redefined. As we venture into this uncharted territory, one thing is certain, it's going to be one wild ride. The silence was deafening. A lone figure hunched over a keyboard, bathed in the eerie glow of a dozen monitors. Numbers scrolled at impossible speeds. This wasn't your average hacker. This was something new, something dangerous. The quantum revolution had arrived, and with it, a new breed of cyber warfare. Imagine a world where the locks we placed on our digital secrets could be cracked wide open, not with brute force, but with the baffling laws of quantum mechanics. This isn't science fiction. Quantum computers, once theoretical, are rapidly becoming a reality, and with them comes the potential for both unprecedented opportunity and unimaginable chaos. The very foundations of our digital world, the encryption algorithms we rely on for secure communication, financial transactions, and national security, could crumble. The stakes have never been higher. Governments and corporations are scrambling to understand this new terrain, a digital battlefield where the weapons are subatomic particles, and the victors control the very fabric of reality itself. The future is uncertain, but one thing is clear, the quantum age has dawned, and the world will never be the same. Hollywood paints a glamorous picture of hackers, digital wizards effortlessly infiltrating the most secure systems. But what about quantum hackers? Do they even exist? The truth, as always, is more nuanced. Quantum computers are still in their infancy. Building and operating them requires expertise and resources far beyond the reach of most individuals. However, the threat is very real. Nation-states with advanced technological capabilities are undoubtedly exploring the potential of quantum computers for espionage and disruption. Imagine a world where state secrets are no longer safe, where the delicate balance of global power could shift overnight. This is the potential of quantum hacking. While the widespread use of quantum hacking might still be years away, its mere possibility sends chills down the spines of security experts worldwide. The race is on to develop countermeasures, to build new defenses for a new age of digital warfare. The future of cybersecurity hinges on our ability to outwit those who would exploit the quantum realm for nefarious purposes. In the face of this quantum threat, a glimmer of hope emerges. Quantum key distribution, or QKD, offers a tantalizing solution: unbreakable encryption rooted in the very laws of physics. Imagine a system where any attempt to eavesdrop on a communication would be instantly detected, rendered impossible by the act of observation itself. This is the promise of QKD. By harnessing the bizarre properties of quantum entanglement, QKD allows two parties to share a secret key, a string of random bits that can be used to encrypt and decrypt messages with absolute security. Even if a quantum computer were to intercept the communication, it could not extract the key without altering the quantum state of the particles, immediately alerting the legitimate users to the intrusion. QKD is not without its challenges. Implementing it on a large scale, integrating it with existing infrastructure, and ensuring its reliability remain significant hurdles. But the potential rewards are too great to ignore. QKD represents our best hope for securing our digital future, in a world where quantum computers threaten to shatter our existing defenses. The implications of quantum computing extend far beyond code breaking. Imagine a world where artificial intelligence is accelerated to unimaginable speeds, where new materials and drugs are designed atom by atom, where the very fabric of reality is manipulated at the quantum level. This is the promise and the peril of the quantum revolution. The ethical considerations are staggering. In the wrong hands, quantum technology could be used for unprecedented surveillance, for developing autonomous weapons systems capable of unimaginable destruction, for manipulating financial markets and undermining global stability. The line between black hat and white hat uses of quantum computing is blurry at best, a moral quagmire that we are only beginning to grapple with. As we stand on the precipice of this new era, one thing is clear: the quantum revolution is not merely a technological shift, but a societal one. It demands a fundamental rethinking of our relationship with technology, our responsibility to use it wisely, and our vigilance in guarding against its misuse. The future is unwritten, but one thing is certain: the quantum age has arrived, and it is up to us to shape its course. Hey there, science fans! Today we're diving into the mind-blowing world where quantum physics meets artificial intelligence. Get ready, because things are about to get really strange, really smart, and really awesome. Imagine a computer so powerful it makes today's supercomputers look like pocket calculators. Now stop imagining, because that future is closer than we think. Quantum computers, which use the bizarre rules of quantum mechanics, are being built right now. These machines, my friends, are not just an upgrade, they are a whole new species of intelligence. Hold on to your lab coats because it gets even wilder. When we combine the might of quantum computers with the learning abilities of AI, we're talking about machines that don't just process information, they understand it, they learn from it, they even dream up new ideas. Let's break down this quantum machine learning magic. You see, regular computers use bits, which are like tiny switches that are either on, 1, or off, 0. But quantum bits, or qubits, are like super switches that can be both 1 and 0 at the same time, thanks to a quantum trick called superposition. This mind-bending ability lets quantum computers explore tons of possibilities simultaneously. It's like flipping a coin and getting heads and tails at the same time. This unlocks a whole new level of learning for AI, allowing them to crunch through complex data faster than we ever thought possible. Think about it. Drug discovery, materials science, financial modeling, problems that take classical computers years to solve could be cracked in hours or even minutes. Hold on to your safety goggles. Quantum AI isn't just a sci-fi fantasy anymore, it's already happening. Researchers are using quantum computers to design brand new medicines by simulating molecules at an atomic level. Imagine finding cures for diseases that have stumped us for centuries. And that's not all, folks. Quantum AI is optimizing traffic flow in megacities, predicting earthquakes with crazy accuracy, and even helping us understand the vast mysteries of the universe by analyzing data from space telescopes. We're talking about real-world solutions to real-world problems, and we're just scratching the surface of what's possible. Now let's get really philosophical, shall we? This fusion of quantum computing and AI isn't just changing the world around us, it's forcing us to rethink what it means to be human. Could these super smart machines someday become conscious? Could they feel emotions or even develop a sense of self? It's a question that keeps philosophers and scientists up at night. As we venture deeper into the quantum realm, we might just unlock the secrets of our own consciousness. Imagine a future where we can interact with AI on a truly emotional level, where machines aren't just tools, but partners in our quest to understand the universe and ourselves. One thing's for sure, the future is quantum, and it's going to be a wild ride. So buckle up, keep those thinking caps on, and never stop asking questions. Stay curious, my friends.